This is Mr. Precella continuing to work the review sheet for my face-to-face college algebra class. This is the second review sheet. We've already done problems 1, 2, 3, so now we're discussing a little bit about functions. On number 4, it says find f of 3, and then you're given a list of ordered pairs here. Well, when you're working with this function notation, the number inside the parentheses is x. When it says find f of 3, that means find the y value. A function is a rule which assigns to each x value exactly one y value. So it's asking, what's the y value when x is 3? Notice the number 3 appears 2 different times, but the ordered pair that you're going to be looking at is the one that has 3 for the x value, not 3 for a y value. So you're looking at this. The y value that's assigned to the x value 3 is 0. Okay. Let me see. The video I just made, we did problem number 3, and for some reason I didn't write the answer down. It is D. We did it, but I just didn't fill in the blank. I want to fill in those blanks there. Now, for finding the domains of functions, there are 2 things you want to avoid. When the equation is written, when the function is written as an equation or as a formula, however you want to call it, we can't have any undefined. We're looking only at real numbers, and when we have fractions, we want to avoid having a number over 0. Remember, it's when it spells no that's the undefined, a number over 0. We also don't want any imaginary numbers, so we want to avoid negatives under the square roots. Those are what we do not want. If there are no fractions and no square roots in the function, then the domain is just all real numbers. And the way we write all real numbers is like this: negative infinity to infinity. There's not a lot of work there. Okay? So all real numbers. If there's fractions in the equation or formula, whatever you want to call it, there's fractions there, we don't want the 0 in the bottom. So we're going to find what we were calling the denominator cut points when we were using cut points to solve inequalities. The denominator can't be 0, so x can't be 2 in this first denominator. What about the second denominator? What would make that give us a 4 over 0? If x were, is that a negative 6? So we want x can be any number except positive 2 and negative 6. If we were told to write this out in words, we could write a little sentence saying the domain is all real numbers except negative 6 and positive 2. In other words, the numbers you can plug in for x. That's what it's asking for when it says domain. What numbers can you plug in for x? You can plug any number in except positive 2 and negative 6. So that's not how it's written. It's written out in interval notation. So let's see. Can y'all write this in interval notation? We're talking about every number except 2 and negative 6. Make sure you have those in numerical order. Open circles mean not including the numbers. We're talking about everything else. So maybe you can see this in your head, or I'll sketch it out. So the interval notation would be negative infinity to negative 6 then negative 6 to 2, and 2 to infinity. So look closely. Don't just, let's see, like this one has a 2 and negative 6 in it. So there's two answers that have 2 and negative, 2 and negative 6. But the one that's the correct one, let's see. Negative infinity to negative 6, union negative 6 to 2, union 2 to infinity. It is A. Notice how the parentheses mean the same as the open circle, not including. Okay. So we don't want fraction, zeros in the bottom of a fraction. We also don't want negatives under the square root. The next two problems, 7 and 8, have negatives under the square root. So problem number 7 says find the domain of f of x equals x over the square root of x minus 4. Well, we don't want the bottom to be 0. Okay, because if we did, we'd have a 0 in the bottom of the fraction. If x were 4, then we'd have a 4 over 0. That would be undefined if you punched it into your calculator. So we're going to solve x minus 4 is greater than 0. Well, let's see. We'll just test. It equals 0 at 4. So if I take, say, I'm just doing a cut point method, a little cut point here. If I test 0, 0 minus 4 is negative 4. No. This was pretty easy to see without really even testing an interval. When would this stuff here be positive? Well, if x were bigger than 4. So the domain here would be 4 to infinity. Notice you're not including the number 4. If you include the number 4, then that would give you a 0 in the bottom of the fraction. Okay? So there's two answers that say 4 to infinity. Can y'all tell which one has the parentheses on the 4? Would be C. Now problem number 8. It's the same thing. F of x, the square root function, but there's no fraction here. Since there's no fraction here, it would be perfectly okay to have a 0 under it. Punch that into your calculator. The square root of 6 minus 6, that would give you a 0 in the bottom. And it's going to give you back an answer of 0. So you're basically solving 6 minus x is greater than or equal to 0. Well, it equals 0 at 6. If I tested something like 0 over here, 6 minus 0, that would be giving me a positive number under there. So this one's okay here. But if you put something like 7, 8, or 9, 6 minus 7, 6 minus 8, that would be negative. So we're including the 6. So the domain would be negative infinity, comma, 6, bracket. Okay? Oh, let me see. Oh, there's two of those. Notice one has parentheses, one has bracket. On this one, there should be a bracket. So maybe you can make some observations. On the one that has the fraction, your answer should not have a bracket in it. The one that does have a fraction, it has the bracket. Why? Because it's saying that it's okay to plug a 6 in there. If you plug a 6 in here, you'll have square root of 0. And if you punch square root of 0 into your calculator, it's going to give you back 0 as the answer. Okay? So remember, when finding the domain of functions that are written either as equations or formulas, whatever you want to call them, if there's no square roots and no fractions, the domain is all real numbers. If there's fractions, you've got to avoid those zeros in the bottom. If there's square roots, well, you don't want a zero in the bottom. You also don't want a negative under the square root. Right? Problem number 9 says find g of a minus 1 when g of x is 4x plus 3. So some function notation. To find g of a minus 1, whatever's inside here, you're going to plug in for x. So in place of that black x, I'm going to put the red a minus 1. And let's see what we would have here. We'd have 4a minus 4. We still have that plus 3 there. So combining the like terms, 4a minus 1. Okay. So we've looked at function notation. When it says find f and there's a number there, you're finding the y value that corresponds to this value. The number in the parentheses is x. In fact, whatever's in the parentheses, that's the x. So when it says find g of a minus 1, whatever's in the parentheses, you plug it in for x. We also looked at domains, and we'll pick up working more of these in a little bit. This is Mr. Precella. Thanks for watching and listening.